Hello class, we're back for Organic Chemistry Lecture 3. All right, gonna quick do a problem drawing fish hook arrows for a radical process. Remember, half arrow for a radical. So let's take a look at this reaction right here. All right, and now this problem would ask you to draw this reaction. What happened? Okay, well remember we had 6 steps, right? So take a look what happened. We have a chlorine, right? The chlorine is going to go onto the our ring here. So this is going to be a halogen abstraction, right? Halogen abstraction is actually pretty straightforward. Let me redraw this, and you should too. Don't be a lazy ass. And show your electrons. And then what's going to happen? Again, halogen abstraction. So we're going to have a half arrow and a half arrow to make our bond. You're going to draw it like this. Okay? And then we're going to go to this, and a half arrow there, sort of going on to the chlorine. And then we're going to end up with our products. Just like that. So pretty straightforward. Hopefully nothing too hard. Maybe, I don't know. All right, let's continue on with more radical electron movement. We're going to see that radical electron movement occurs, or is generally classified, I should say, as either initiation, propagation, or termination. Okay, so free radical reactions, let me back up a little bit. So free radicals, you've probably heard of antioxidants, free radical scavengers. So in our metabolism, or if you get hit by UV rays or whatever, X-rays, you can get free radicals inside your body. They're very destructive because, why are they very destructive? Because it's a chain reaction. Until something hooks up with the free radical and terminates it, it can do a lot of damage to a bunch of different molecules. So that's why we have it. So we're going to have initiation, propagation, termination, right? For radical electron movement. But that's also why it's so destructive in a human or animals, living things. And that's why a lot of people take antioxidants. Okay, generally classified as initiation, basically creates a free radical. Propagation, occurs when free radical moves from one location to another. And finally, termination occurs when radicals are destroyed. Okay, so those are the 3 ways to classify are 6 steps, okay? Which I'm gonna now write those back on the board and show that, okay? Why don't you write that down, or I guess you can stop the video to write that down. If you're even writing down notes. So, homolytic cleavage was our initiation step. There's other types, that's the only type we're going to be worried about. Okay, I'm going to draw that here. I'm drawing it this way so I can put these all on the board. And this here we had, say, light or heat, okay? And then it created 2 free radicals. Right? Homolytic cleavage. Then we had 4 propagation steps, okay? Addition to a pi bond, hydrogen abstraction, halogen abstraction, and elimination are all propagation steps. So let me write those here. Hydrogen abstraction. So we're going to end up with enough room on the board. Halogen abstraction. Elimination. Okay, and again, all of these are propagation steps. All right, let me quick write these out once again. And you should be writing these out also. So again, right, addition to a pi bond, so we're adding this halogen here. And we're going to get this. Notice the propagation step. So notice what happened. We still have a free radical. We had a free radical. We still have a free radical. That's why it's called propagation. Let's take a look at hydrogen abstraction. So again, right, hydrogen abstraction. Note, once again, free radical. In the reactants, in the products, free radical, propagation. Let's take a look at halogen abstraction. So again, here we have a free radical. This is carbon of some sort. Again, free radical, right? Halogen abstraction, we end up with a free radical in the products. Again, propagation. And I'm going to run out of room. Elimination reaction, that was the opposite of addition to a pi bond, right? So here we're going to end up, we're going to have blah, blah, blah. Like so. And elimination. Again, what do we end up with? A free radical. So again, all propagation, okay? All 4 of those steps of propagation. We have one more, but I'm gonna have to erase to make room. Okay, what do we have? We have termination, correct? Which would be coupling, right? But, yeah, not gonna fit there. Well, here, I guess I'll just erase this. Again, termination is gonna be coupling. Coupling is where we get rid of 2 free radicals at one time. And then termination. Gonna change chalk. Here we have coupling. There can be different types of coupling, okay? In this example, I'm just going to use 2 halogens that are free radicals, okay? But there are other types. Remember we had a carbon free radical? Well, that could couple to a free radical halogen. That'd also be termination step, but anyway. All right, so there we go. So those are our 6 steps, again, divided into initiation, propagation, and termination. Now let's take a look at an actual reaction where we get a bunch of these that occur. And again, that's why free radicals are so damaging, because they end up with a chain reaction. It can cause a lot of damage in a living organism, right? So let's take a look at radical chlorination. We're going to add chlorine to an alkane. In this case, just a methyl. So radical chlorination. All right. So again, we're going to have an initiation step. This would be, again, our homolytic cleavage, okay? So we're having chlorine. And again, when you draw this, you better draw all the electrons. So again, initiation step, right? Heat or H nu. Again, this is our homolytic cleavage. Right, and what do we get? Nope, not X. 2 chlorine radicals. Okay? So again, that's the initiation step. Now it is possible in this reaction, some of these would come back together and they'd terminate, right? But we're going over the whole reaction. We're adding chlorine to methane, so although that would happen, other chlorine molecules would not, and we end up with this. Oh, let me write here, propagation. Okay. Again, here's going to be our methane. Why do I keep drawing X's? We're dealing with chlorine, not a generic. Here we're going to have hydrogen abstraction. Okay, we're going to have hydrogen abstraction. And we're going to create a methyl free radical, right? Like that, right? Okay, and you can probably guess the next step. We have this methyl free radical. Okay, again, this would be hydrogen abstraction. Okay, now we have this methyl free radical. And we're gonna go to another propagation step. All right, and so then here we're gonna have a halogen abstraction. And I'm not leaving myself enough room here. Plus a chlorine radical, okay? So again, in each propagation step, all we're doing is we're transferring the free radical around. We're getting another free radical, okay? In this case, we got another chlorine free radical. And then there's different reactions that can happen. Okay, I'm not covering all possibilities, all right? But then we're gonna have termination. And we can have several types of coupling, okay? This could again couple with another chlorine free radical. Like that, okay? Or it could combine with a methyl radical. Forming methyl chloride again. And I don't have enough room. Or we could have two methyl free radicals joined together. I'll draw that over there, right? So, so for termination, there's several different options, right? And I'll draw the last one over here. Sorry, there's not enough room. That's too bad I had to erase that.